All right, guys, so we're starting a new chapter today. We're going to be looking at some other 3D figures. Today, we're going to be talking about pyramids and their nets. So this net on the left here, you've seen it before. If I folded it up, you should know we're going to get a triangular prism. We've looked at those. We've found surface area with those. But now we're going to look at a pyramid, okay? This looks a little funny. It actually looks very dangerous. Like if it were made out of metal and you threw it, it was going to hurt something. If you see something that looks like a dangerous object when you see a net, it probably is a pyramid. The way we name pyramids is the shape of their base. We're going to say the shape of this base is a square. So we have a square pyramid. So these are a little bit different. They're not going to have a bunch of rectangles hanging around. They're generally going to have some sharp edges or some triangles. We're going to look at some critical points of these things. Let's start with this net over here. It's the same net we just looked at. We have a couple of things that are easy and we've seen before. This arrow down here is pointing at the base. Looks like we have a square base on this one. When we start looking at the triangles, these are the walls. These are our lateral faces. The lines that connect the walls are the lateral edges. And then we have this other thing over here that we haven't had before. This is pointing at this line right here, okay? When I tip this up, and if I kind of look at this one over here, you can see it. It's this line right here. It's not really the height because it's like the length of the ramp going up to the top. This is called the slant height. And we're going to use L, a script L, to denote slant height, okay? So we have all the same things on the other side, except for we have one thing that we didn't put, and that's going to be the vertex. There's other names for it, but that'll work for us. Of course, that blue line we drew just a second ago, that's our slant height again. And remember, that's L. And then this line inside here, the one that goes from the very tip all the way to the base, I don't know what I just did, sorry. That is the height, the actual height. This height is an H when we look at some of our variables. The one other thing I want to look at, and I've kind of already got it outlined, is this triangle that you're seeing that's outlined in blue, green, and red. That's a slice. Like just if I cut it kind of with a knife, if it was a giant block of cheese, I could cut out that slice. And what we have here is the height. We also have our L, and this down here is the apothem. If we drew this piece right here that I just drew, let me draw it in yellow so you can kind of see this thing here. That's our apothem right there, and that would have been our radius, okay? So we're going to look at a few things with that here in a minute. But right now, let's kind of look at the differences between prisms and pyramids. So there's some similarities and there's some differences. On the prism, it's named by its base, which is exactly how we name a pyramid. So you look at the shape of the base, and then you put pyramid or prism on the back. The number of lateral faces, now remember these are the walls, depends on the number of sides on the base. On the number of lateral faces on a pyramid, it's the same thing. The number of sides on the base. So if we have a square prism, a square has 4 sides, there's 4 lateral faces. Same thing on a pyramid. A square pyramid has 4 lateral faces because its base is a square. On the bases, there's 2 bases on a prism. There's the floor and the ceiling. But if you think about a pyramid, there is a floor, but there's not really a ceiling. It's just the walls coming together. So there's only one base. When we did lateral faces for prisms, they were always rectangles. But if you look at the lateral faces of our pyramid, you'll notice that they're all triangles. The height on a prism is just found by the lateral edge. If the height on the other one, on the height on the pyramid, though, is not visible on the net because it's all folded out. Like if you look at this folded or this net right here, you can't tell the height on it because it hasn't been put together. So I'm just going to put not visible on net. That looks terrible. On net. There we go. And it asks on the last one, on the prisms, is there a slant height? There isn't, because it's like kind of a ramp kind of look on the walls. The slant height only goes with the pyramids. So that's a lot of stuff to talk about. Let's look at some things on the next page. Over here it says determine whether each net will form a pyramid when folded to make a solid. Now I'm going to want you to pause this for a second, try that out, and I want you to name it as well. So go ahead and give it a shot. Hopefully, guys, you tried this out. If you look at A, these red lines right here that I'm drawing will all intersect down here on the base. This one would be a pyramid. It looks like we got a square pyramid. On the next one, these lines are the ones that should touch the base, but when I do that, I only count 5 lines, and it looks like I have 6 on this hexagon, so there's not enough to close it off. So this is not a pyramid, so I'm not going to name it. Then this last one, it really looks a lot like the one on the front. It kind of looks like a throwing star. These sides would all fold up, and then you'd have your pyramid, and it looks like it would be a triangular pyramid. So be careful when you look at those, but like I said, a lot of times they look really dangerous like that one. Another way to draw this one to make this actually work would have been to put a triangle on each side like this. You can see that looks like you could throw it and stick it in somebody. So let's identify a few things, then we're going to get into some actual problems. The first thing it wants us to identify is the vertex. Well, that's the very tip of the pyramid, so it's point E. There are 4 lateral faces because its base has 4 sides. I'm just going to write them in real quick. We'd have triangle AEB. Remember, those don't have to be in any order, those letters. Triangle BEC. I see triangle CED and triangle DEA. Remember, those are the walls. Okay, I'm going to put that right here. So everything but the base. Lateral edges, guys, the lateral edges all intersect with that vertex point. So I have segment EC, segment EB, segment EA, and segment ED. Now those can all be flipped. It could be CEBE, but as long as they all have the E in it. And then the base edges. Well, I kind of already outlined those a minute ago, but here they are. There's 1, 2, 3, 4 of them. Let's see, I've got edge AB. I've got BC, CD, and DA. So make sure you understand what those are. There's not a lot to it. Remember, lateral means walls. Now, we're going to get into some problems here. They're not always the easiest thing, so kind of watch and listen real carefully. If you have any questions, they'll come into class tomorrow and we can talk about it. We're going to find the slant height, which is L, on this problem right here. Okay, so they don't want us to find anything like surface area or volume. They just want us to find this height that we don't yet know. So here's our pyramid. We're going to go ahead and say it's a square pyramid, so that means all the sides on the base are congruent, okay? Now, when you're doing these, it's kind of hard with perspective to always get them right, so I like to redraw the base. So this is just the base. The things I know about the base are that each side is 12 units long. Now, this line right here that I'm outlining in blue, I'm going to go ahead and put that right here, okay? That is my apothem, if you don't remember. So there's my apothem, which means I have a radius, which doesn't really matter too much to us right now. But since this was a square, that means we just formed a 45, 45, 90 triangle. Now, that's not super important to right now, but I want to make sure you understand something. If the side is 12, we should know that a line that makes the apothem splits that in half. So each of those sections is 6. The apothem, since it's 45, is equal to x, but I know this is also x, so I know my apothem is 6. So now, and I know this is kind of weird, I'm going to redraw the slice. Okay, I'm going to outline the whole slice in blue. There's the height. There's that apothem we found, and there's the L that we want to find. Okay, so I'm going to redraw that triangle right here. There's that height that's 8. There's the apothem that we just found out was 6. And there is L, the slant height. Okay, so be really careful when you're finding these out, because now it's just Pythagorean theorem. 8 squared plus 6 squared equals L squared. And we should know 6, 8 means it goes with 10. So our answer would be 10 units. So there's a little bit you have to do there, but it's set up pretty nicely for you with a 45, 45, 90 triangle. Let's look at the next one. Says if the perimeter of the base is 160 units, find the height. So it looks like they gave us the slant height this time, that red line right there. And technically they told us a side length too, okay? They told us that the perimeter is 160. Well, there's 4 sides, so 160 divided by 4 gives me 40 for each side length. So I'm going to draw the base. It's a square. I know each side is 40. I also know that I have an apothem right here. I drew it in blue into a 45, 45, 90 triangle. So same as last time. And if one side is 40, that means half is 20. So now I can find A, which is 20. It's the same thing. So I'm going to draw that triangle again. I'm going to outline it right now. There's the height. I keep hitting that, I'm sorry. There's the apothem. There's your slant height. That's what it looks like right there. I know that my apothem is 20. I don't know what my height is yet, but I know that my lateral height, L, is 29. So again, I can throw it in the Pythagorean theorem. This one's a little bit tougher. H squared plus 20 squared is going to equal 29 squared. That's H squared equals 441, because that's 400. And I subtracted it from the other side. Then we take the square root of both sides, and the square root of 441 is 21 units. So guys, these are a little bit complicated. Like I said, if you have questions, you can ask them tomorrow, but those are fairly straightforward as far as they use the 45, 45, 90, so the apothem ends up always being half of a side length. Now let's look at the theorem. Now, oops, sorry, we got 2 more. It says find the indicated values. Now, I don't like these pictures. You really need to look at it carefully. This is a pyramid. It looks like it has a triangular base. This is the base. You can kind of see them, but it's telling me it's an equilateral triangle as well, with a side length of 32 square roots of 3. So I'm just going to kind of re-sketch it. I know this side is 32 square roots of 3. But guys, it still has this apothem right here, and it still has its slant height. So I'm just going to sketch in my apothem, because I have a feeling that's what's going to come down to. Now, it asks us to find the slant height, that right there. But to find it, we're going to need to know the height and the apothem so that we can use Pythagoras. Now, I know this is an equilateral triangle, so now I have a 30, 60, 90 triangle. Okay? I know that this apothem cuts the bottom length in half, so I know this is 16 square roots of 3. Now, if you don't remember, if that's my 30-degree angle, my template says that this is the x square roots of 3 side, this is the x. So if x square roots of 3 is 16, that means my apothem is 16. So I have part of what I need already. So I'm going to go ahead and draw my slide.